analysis school of magic where learning physics together is magical. Let's go to question 39. A stone of mass m is dropped from the tall building. So at the top building, you drop a stone of mass m. There is significant air resistance. So air resistance is present. The acceleration of free fall is g. So positive g. When the stone reaches its terminal velocity, which information is correct? You have a keyword, terminal velocity. Terminal velocity is just another term used to mention when an object under air resistance suddenly falls with constant velocity. So, which information is correct? So in order to understand this, let us note down the different magnitudes in the table. There is a magnitude of acceleration of stone. There is magnitude of force of gravity on stone, and there is magnitude of force of air resistance on stone. So, if you see the previous video, this is what happens when stone falls. When t equal to 0, let's give force of air resistance a symbol. Force of air resistance. Your air resistance, force of air resistance is also equal to 0. Magnitude of acceleration of stone. Let's give this a symbol where A for acceleration. Therefore, acceleration of stone as AS is equal to positive g. Why? When it's falling, when you have object, why does it fall when you let it go? It's because it's being pulled by gravitational pull. But t equals 0, when there's no air resistance because it's not yet moving. What is its acceleration? Its acceleration will be positive g. Okay? Give you a few seconds to think about that for a while before we move on to the next component. Now, magnitude of force of gravity on stone. This is actually a trick. Why? What is magnitude of force of gravity on stone also known as? This is also known as weight, equal to mg. So what happens to your weight here? Your weight is still mg. Let's say time increases. What happens to your air resistance? It also increases. Okay? Actually, it's not correct to put increases with a equal sign. So let's say when time increases, air resistance increases. What happens to your acceleration? Your acceleration of stone actually decreases. Okay? But your weight remains the same. Weight always remains the same, whether it's air resistance or no air resistance, we drop it. Why? Imagine, when you let it go, does it still have the same weight? When it's falling, does it still have, is it still there? It's still there. Okay? So no matter where it is, its weight is always present. If weight is to decrease, would mean suddenly the mass will decrease, which is not really true. So what actually does this mean? The best way to understand this is to draw a point mass diagram. When there is no air resistance, how many forces is working on this object? Only one, which is weight. But if A resistance is present, how many forces exist on the mass? This mass M. 2. One is weight and one is A resistance. You have two forces. What happens as, let's say, in this case, V is equal to 0, so V increases. What happens as more time passes? As your V increases more, your A resistance will also increase more. When that occurs, there will come a point where your weight and your A resistance will balance off each other. Okay? There will come a point when weight will be equal to your A resistance. When that occurs, what happens? Let us write equation for that. Positive downwards. Resultant F equal to MA. W positive minus A resistance equal to MA. When these two are equal, what must MA be? MA will be equal to 0. Why? When E is equal to 0, notice weight becomes equal to A resistance. When acceleration is equal to 0, what happens to your velocity? Your velocity actually then stays constant. V will then be constant and it will be known as terminal velocity. So let's go back to this question. What are the values that will occur when you reach terminal velocity? Acceleration of stone, because terminal velocity means constant velocity. If constant velocity means acceleration cannot exist. So this part, acceleration will be 0. Trick question, what happens in all these cases? Your weight still remains the same. So in this case, weight is always mg. And what happens to your magnitude of, what happens to air resistance? Your air resistance will be equal to your weight, will be equal to mg. So the theme of this question again is what happens at terminal velocity. Always remember, air resistance balances out weight. When it balances out weight, acceleration gets reduced to 0. When acceleration gets to 0, therefore your velocity enters terminal velocity. To make it easier for you, why I say this now? When your air resistance is equal to weight, this will lead to your acceleration entering into 0, which will lead to your V equal to constant. And this phenomena is called reaching terminal velocity. I hope you understand this video. If not, please replay this video and provide me some feedback. The next few videos will help you to apply this much more easily.